Alright, so now that I have the ratchet straps down to hold the batteries, the other thing that I've done, and I'll show you quickly, is I needed a way to secure the batteries so that they wouldn't slide around and move. So I actually took screws for bolts that came with the batteries, and I used a DIN rail. And so the DIN rails are fairly easy to find and use, and so just connected those back into the rack mounts, and so that'll make it nice and easy to connect back in and make sure that the two batteries aren't sliding side to side. They shouldn't move going backwards because they'll come back and hit this bracket here. And so on the front, I'm going to take this L bracket and I'm just going to stick it there so that the batteries won't slide forward. So this will keep them from sliding back, that will keep them from sliding forward, this will keep the two batteries tied together. Shouldn't need to put one on the second side. This should be more than sufficient for this end. May have to trim this off a little bit, but I don't think so. So next we're going to come in and take the rest of the equipment, put it on top of the battery. If you remember, on the bottom of my board I just have the Velcro strips. They're going to go to the Velcro strips on the top. So hang with me and we'll put that together. Alright, so I can hear the Velcro sticking and coming in. This will let me come back, tie in the cables. I'm going to take the Victron and put it here out of the way so that I can take my wall this way and then take the wall back here to minimize the space that I'm taking up. The one challenge I'm going to run into to put the bench back in is the brackets here. So I'm going to use these same L brackets. This is just 2.5 inch L brackets. We'll put VHB tape on each side, and I'm going to put one on either side of the inverter. Put the screws in the floor. That'll keep this from moving, keep it against the wall and away from the wall, and it lets me pull it, lay it down, put the bench back in, set it back up, and then I'll be able to come back and secure it to the floor as well. So it's a bit of a tight space, but everything's going to come in and fit, and then once I get it all tied up, it should be nice and organized. So I can put my bracket here. So that should give me a nice tight fit, coming in and holding the batteries from sliding forward. So we'll see how that goes, and then I'll use the same brackets for securing the inverter. So let's do a little bit of a status update. So I've gone in after I put the plywood and the different components back up on top of the batteries. And I've gone back and reconnected the multi-plus from the positive and negative into the bus bar again. I had to come back in and connect the positive into the fuse holder. I did switch out the 400 amp fuse for a 200 amp fuse. I've got it on disconnect at the moment on the disconnect switch. I installed my shunt, but if you notice I have this little bar that I've used and I received or ordered from Explorers.life. It's a good little connection that I can use to connect the 5/16 with the 3/8. And so I put in the smart shunt here. Unfortunately, the wire that I originally had, I need to tighten this down, the wire I originally had coming in from the battery to here had a 5/16 lug, so I had to make another wire. So this one goes from 1/4 on the battery to 3/8 here instead of the 5/16. This bar has a 5/16 3/8 connection, so we'll tighten those up. I've reconnected back in the DC to DC inverter, excuse me, DC to DC converter. I'll set this back on for sitting there for a second. I came in and took the shore power, connected it into the inverter. So I've got my hot, neutral, and ground. I will connect another wire from the frame of the inverter back into the ground bar as well. I've purchased some 6/3 wire that I'll use to connect for the AC out, and so I've actually run this back over to the panel, and then I'm leading to work at coming this in. So this is actually a 6/3 with a ground. I don't need the black, white, red, and a ground. I'll use the black for the hot, the white for the neutral. I'll trim away the red, and I'll use the ground for connection into the ground bar on that side. The other piece that I've rearranged, so I'm going to bring this around a little bit more here for you to see. So I've rearranged this bar. This used to be up here, and then we had the solar charge controller was here. So now I've disconnected some of the other pieces. I need to take this one off. This was going to the solar charge controller, then back over to the batteries. So I've connected the DC to DC from the terminals into the positive and to the negative. I chased these wires, and coming from this bar, it goes into the Airstream disconnect switch. And so now this will allow us to go from 24 volt, convert down to 12 volt into the panel here, but still leverage the disconnect switch for any of the appliances inside. The other piece that I've installed, and part of the reason of bringing this bus bar down, is I've installed a DIN rail, and instead of using a fuse, I can find it. Instead of using this fuse, which came off of the MPPT, and it went from the positive, battery positive, over to the bus bar here, I'm going to be taking the MPPT directly over to the Lynx distributor. And in doing that, I'm going to take the PV wires that are still connected, and I've got them taped up because it's a sunny day and it's hot. They're coming into the PV positive and negative. I'll go from the wires here over to the Lynx distributor, and this will be fused as well. So that'll let me to eliminate connecting the charge controller here and let it connect back into the Lynx distributor to charge the batteries and work with the inverter. Now, in doing that, I'm going to take these PV wires, but to give myself a disconnect, I'm going to install this breaker. So this is a 63 amp breaker. If I can find a smaller 40 amp, I will. But you install this DIN rail, it just slides on. You push these little levers on the bottom. It locks in place. And so now PV wire coming in, the charge wires from the charge controller coming back over to the Lynx distributor, and now I'll have my disconnect off or on from the PV wires coming to the charge controller to turn this off if I need to do any work on the panels or in this equipment without having to worry about having hot wires. So we'll continue on as I go through the 6.3, connecting that up. I've got to drill a hole coming back in for the 7-way, and I'll show you those as I go along. And we have a new hole right beside the tire. One of my last challenges coming back in was how to mount the Victron Multiplus. So the plan I have at the moment is to come in. I have left over from another project some 1x1 pieces of wood, but I've cut 8 inches. These should fit well here as a support from the bottom base of the Victron Multiplus. Then I'm going to use some VHB tape, and I'm going to take these to the bottom. Next, I'm going to take these brackets, and I'll do 2 on each side, and I'm going to use the bracket. I don't know if there's not enough wood to screw in there, so I'm going to use VHB tape on the sides for both of those 2 brackets. So I'll put 2 on each side. Then I'll be able to take and screw the brackets down into the floor to hold this in place. The overall height that you have is the Multiplus is 14 3/4 roughly. I don't remember the exact measurement. Up to the bottom of this bracket. For the bench, I'll show you here. So up to the bottom of this bracket is just under 17 inches. It's about 16 7/8. So if I take this 14 and let's say 7/8, just to be on the high side, 15 inches, add an inch, that'll bring this up to just under 16 inches. That'll give me just a tiny space of about an inch or so below the bench where this is sitting. So I'm going to put these on, put the brackets on the side, make sure everything's good and level. The other thing this is going to help with is one of the challenges run into is my 10-2 wire, my 10-3 wire coming in from the shore power. My 6-3 that I use going back over to the breaker panel doesn't bend well. So this will actually also lift the Multiplus off the ground by that inch. So there's not as much strain on these 2 wires coming back in. So we'll glue these on, put the brackets on the side, lift this up and have that ready to go. I'm not going to screw it into the floor yet until after I put the bench back on, because otherwise I won't have a way to get the screws into the bottom of the bench, because this will be directly underneath that. So I'll get everything ready to go. When I put the bench on, I'll lift the Victron Multiplus back up. We'll then use the screws to put that down into the ground, and we'll see how well this holds in place. And I'll check it after the first couple of trips, every trip, just to make sure that things are running well. So let's go in and talk about the final system setup that we have. So I have the Multiplus up and running. I have it connected back in, obviously, to the shore power, back into the AC breaker system. I have my main connections coming in to the Lynx distributor, going back over to feed the batteries and the rest of the equipment. So it is currently set up on an inverter. It's an absorption because the batteries are at right at 100% full. I've had them off and on a little bit, just doing some testing. As you look at the wiring that comes into the system, I have the 2 4 wires coming in from the Multiplus for the positive and the negative, with a 400 amp fuse. I went ahead and bumped it back up to 400 amp for those times where I might be doing power assist from the Multiplus to help out run additional AC devices in addition to what's being run off of shore power. So if for whatever reason we slightly exceed the capabilities of the AC shore power, the Victron Multiplus can come in, use power assist, pull battery power to feed into the AC devices. And so I wanted to make sure I had plenty of capacity on that side. Probably could go with a 200 amp fuse, and I may change that over time. Coming off to the side, I did connect in the monitoring devices, the Cerbo GX. I've got an MK device for monitoring into the Multiplus as well. And then for the BMV 712 for the battery shunt for the monitoring. Those are connected into this one with a 40 amp fuse. A lot of the diagrams I see actually show connecting it to the positive and the negative bus bars on the end and not actually fusing it, but I just went ahead and used the slot. It was free and available. I have my chassis ground coming back in. Normally I would take the chassis ground and tie it into the ground through either the negative ground that we already have in the system, but in this instance one of the challenges I ran into is I literally just ran out of space for the 6-gauge wire on my bus bar. So instead, I took it from the links distributor down to the chassis connection on the inverter for the multiplus. The multiplus is coming back over and is tied into the bus bar, so it still has a path from the back to chassis ground, back through the inverter chassis, back over to the ground bar. Coming back in, I have the, beyond the chassis ground, I have the MPPT for the blue solar 150/35 connected in for the positive and negative here on a 40 amp fuse. And Victron specifically on this unit asked that it be a minimum 40, high end of 45, and so I got a 40 amp fuse on this end. For the DC to DC, these are coming back in from the links distributor back over to the Orion 2412 DC to DC converter. And so that comes back over, it connects back in, and allows us to power the 12 volt connections on that end. I also have my disconnect switch for the batteries off of the positive, coming back into a Blue Sea 200 amp A&L fuse that we have connected here. Positive is on the top, negative is coming on the bottom battery, and the batteries are connected in parallel, going positive to positive, negative to negative. I do have 2 connections coming in from an Ethernet standpoint. One to give me Bluetooth directly off of it is a VE Bus Smart dongle, so that I can come in with the Bluetooth and measure and look at what's happening with the multiplus. I also have this blue cable, and again, no difference in the color, they're just basic Ethernet cables. The blue one is connected back over to, or will be connected over to, the Cerbo GX. I'm actually running into a little bit of a challenge at the moment where when I plug in the Ethernet connection, the multiplus shuts off. So I have all the equipment connected into the Victron Energy VRM portal, looking at the logs, and I have a request in the community to figure out what's happening on that end. But if nothing else right now, the Cerbo GX is giving me data directly back from the MPPT and from the Smart Shunt, coming in through a VE direct connection on the back of the Smart Shunt and a VE direct connection on the back of the MPPT. So let's look, kind of hard to see here, but one of the things I ended up having to do was drilling another hole. I'll take you outside and we'll look at that. I had to come in and drill another hole to bring in the 7-way, to bring in my power cable for the electric jack, and I have another cable here that I'm secure, which is for my tire minder for the monitoring TPMS system for the tires. As you flip around, I did have to make a change, and this is a little bit of a mess. I apologize. Let me undo this, get a closer view. So I made 2 changes on the board that was here. One, I took the MPPT off and connected it there. We'll see how this goes. Victron's specs say to install it vertical. I've got it horizontal here, obviously. We'll see if that causes any problems with heat or the heat sink on the bottom. But I do have the MPPT connected back into a breaker so that I can turn off the solar panel connection. So any of the charges coming in from the yellow and the green wires, the yellow being your panel volt positive and the green being the negative, comes into the breaker comes back out into the MPPT, and this lets me isolate this equipment from the solar panels and not have to worry about getting shocked from any of the power coming in from the solar. Now, one of the other challenges, and I'm going to have to reconfigure some things on this end, will be the solar panels, and I'll talk about that in a moment. So I have removed some of the ground connections that were no longer needed, i.e. the connection over to the MPPT. I've added others back in, and I importantly have tied in the DC to DC conversion. So I've left the original connections for the wires coming from the positive and negative off of the fuse panel and the system. This allows me to continue to use the disconnect switch that's here, so that if I want to cut off DC power from all the appliances in the Basecamp, then I can connect those in and make sure that the batteries aren't getting drained from phantom draws on the DC system. And I just use the solar panels once they're reconfigured to continue to charge the batteries without any draw. If you do notice that breaker, I did install what's called a DIN rail, D-I-N, and that is just something you can screw on and the breaker clips onto that. So we're going to test that and see how well that works. I did have to move the connections for the 7-wire, and so I moved it from over on the side here because, well, honestly, I ran out of length of cable, and I didn't want to have to redo all of these cables coming back in and extend them. So I just moved the unit to this side to make sure that we could get the connections in there. And I'm going to find some way to come and close up this hole for now. I may put in a fan for the summertime to take heat, like a computer fan, to take heat out of the system. But other than that, it's closed up for now. We're open for now, and then I'll close it up, put some tape or something on it so that there's not heat coming into the system. So that's a high-level overview of where we are and what's working. I can run any of the AC devices, the DC devices off of the system. And other than the Cerbo GX problem I'm having at the moment, no major issues as we're coming through. I will, again, set this up after I put the bench back in. So I'm getting ready to connect the bench here shortly. Set those back in. I'll set the Cerbo, I'll set the Multi-Plus up, use the brackets to screw into the floor, put the covers back on, and put the table back in, and we should be ready to rock and roll. Now, as I get into the solar, what's going to have to happen to the solar is I'm getting usually about 21, 22 volts coming in off of the two 90-watt solar panels. They're 12 volt, 90 watts a piece, and their max at the open voltage is getting it up to, can get up to about 24 volts. We'll really need, for a 24 volt system, you need a minimum of 28 volts to charge the system. So I'm going to have to reconfigure those two solar panels in, I believe it's series instead of parallel, so that they will start coming in at around 48 volts instead of the 21, 22 that it's doing today, and that will let us use those two. I've ordered two additional 200 watt panels from Rich Solar that I'm going to install, so we'll see how those 200 watt 24 volt panels will work, and I'll show you a video on those as I connect. So I hope this helps. Let me know if you have any questions. If you see that I'm doing anything wrong, please let me know. And I think we're good to go on this installation because it is a Wednesday and we're going camping on Friday. Let me know if you have any questions. Hit like and subscribe, and have a great day.